action. Okay, so looking at this, this lesson is very related to the last lesson. In fact, whoa, I'm up on the screen. That's wild. Okay, so very related to the last lesson. In the last lesson, we learned about SRS, right? Simple random sample. And we used the random number generator for this. And I'm sure it's RNG, but I'm going to go ahead and make that R hashtag G. Okay. Random number generator. All right, so an example of SRS, if I was trying to get an idea about all the trees on campus, right? All the trees on campus. First, I'd want to get a sample, because the population is like hundreds of trees probably, or 100. I don't want to look at every tree. So I need to find a sample that I'm creating through a simple random sample. So if I had that case, that situation, I would go to every single tree, and I'd either tag it or put a number on every single tree. So every tree would have a number assigned to it. Then I would go to my random generator over here, right? I go to my random generator and I'd say, I need my sample to be a group of 10. I need the minimum value to be 1 because that's the first number I gave to a tree. And 100 is the maximum value. And I don't want any duplicates, so I put that as false. Then I go ahead and calculate. And from there, I have a perfectly random sample. 4, 99, 88, 23, 17, 61, 30, 50, 62, 54. Okay. This is the most random way that you can find your sample, but it's not always possible. There may be too many people. There may be, as we get to the stratified sample, you'll see there's other things we have to consider, right? Maybe the type of tree. I don't want it to just be like one type of tree. There's other things. The height of the tree we can have as a modifier, one of the variables we need to look at. But in SRS is the basics. And this random number generator, you're going to use that for most of our other samples. So get used to using that. It's on Edmodo pretty much on every day's post. Okay. Now the key for this is, and this is actually how we're going to apply it later. I don't think we touch on it in today's classroom homework, but we use a proportion to relate the sample to the population. So if I went out and looked at 6 trees, and I found 3 of the 6 trees were oak trees, then I would set up a proportion to see, well, how many oak trees do I have in the population? Here's the sample I took. Here is the total population. Cross multiply, it would be 6x is equal to 300, so x is 50. You can even see that. 3 to 6 is half, right? 3 out of 6 is half, so it would be 50 out of 100 would be half. You're going to keep the same ratio because it's a proportion, they're equal to each other. Okay, so the first one I'm going to start with is the laziest person ever. Laziness brings you to do the convenience sample because it's convenient. The convenient sample is taking a sample that is maybe it's just right around you, right? Maybe it's it's whatever the sample is chosen quick to minimize the time, the effort, and the expense. Because it costs a lot of money to go and say I want to give a questionnaire to every student in the district. That takes a lot of money and time. That would be like a small team would be doing that. They have that data team at the CERNA centers. But if you were doing a convenience sample, you're going to be prone to serious bias or error. So think about this. These actually, anybody know what these are? Guess what these are. Cars, 6-wheeled cars. That makes more sense than these are tables at lunch, right? 6 people at each table. I knew it'd be a mystery. I didn't have the room to put little smiley faces.
I thought they were
lunches.
desks in the classroom.
That could be it. Okay, so desks in the classroom. Tables have 6 desks. It doesn't matter at the table. But if this was you, right here, it's not me. I am not sitting at the table. It's you. It's you. Where's the sound effect? Thank you. All right, so if this is you sitting at this table, a convenience sample, if you wanted to find out the population of all the tables, a convenience sample would be for you just to get the questionnaire of the people right around you. You didn't even want to get up to leave the table. Convenience samples, we're not going to create because they're mostly useless, but we have to be able to recognize it when we read about it, when they give us the details about it. Basically, if it looks like there's going to be some serious bias or error, and it's because what was chosen is right around it, you know it's a convenience sample. Not the example we want to follow. Systematic sample. Now, all you have to do is order the objects into a natural order. Okay? So an example is arrival times of airplanes. If I was at an airport, it'd be easy to sample, put that in a natural order. The first plane is number 1, second plane is number 2, third plane is number 4. Just kidding. Number 3. You could also do it for incomes. If you all had jobs, you can make it incomes, just least to greatest, right? So you're using the natural order, putting the objects in natural order, then you select the nth option. So for instance, if here are all my objects, if I was using the third option, that means I'm going to skip. I'm going to start at some place. If I started on D, I'm going to show you how to do that. If I started on D, I would go, here's 1, 2, 3, I'd circle G. Then I'd go 1, 2, 3, I'd circle J. 1, 2, 3, I'd circle A. So we have to first figure out what our increment is, how many we're going to skip, and then we also have to figure out where we're going to start, and use the random number generator for both those. Okay, so, or actually the increment is going to be the number in the population divided by the number in the sample we're seeking. So we look here. For this example, we want to find the sample of 4 objects from the population. How many are in our population here through L? 12. So I know that my increment here is going to be, I'm going to go ahead and put my population as 12. I want to have 4 objects in my sample, so then my increment is going to be 3. We're going to select every third entry. But here's the deal. If every single person just stopped at that, they said, I got my increment, guess what? I'm going to start here. I'm going to go 1, 2, 3. Then everybody would end up with the same exact sample, right? So first you got to figure out where you're going to start. I can either start at 1, 2, or 3. Right? You get to start at 1, 2, or 3. Because I'm doing every third, that covers all the places I could start at. I don't do any further because if I started at 1, then it would be 1, 2, 3, and that's just like starting at 4. So you look to see how many spaces you're gonna skip. Every nth option, we're going to every third option, and then I go right here. I go to my calculator. I just want one random number. My minimum value though can't be 1, because that would be you're taking every. Oh, actually, in this case, we can't have 1. I'm sorry, we can't have 1. We're going to start either at the 1, 2nd, or 3rd option. Let's have no duplicate entries because we only have 1 anyway. It doesn't matter. And we ended up with error. Oh, hey, we need 1. So I went in and said I want 1 random number between 1 and 3. What did they give us? They gave us 1. So I know that means I start here at 1, and I'm going to go 1, 2, 3, D. 1, 2, 3, G. 1, 2, 3, J. 1, 2, 3, A. Okay. When you get to the end, you start over. All right. So actually, I'm going to go ahead and say that we're going to start with wherever we selected. We're starting the first position. That's going to be our 1. That's easier to remember, and you end up with that anyway when you cycle through. Okay. So looking at that, we started at 1. We knew it was every 3 because it's 12 divided by 4. 12 in the population, 4 in the sample. So we then had to find the starting object with a random number generator. This part right here, this part, the starting, is something you'll have to kind of work and do a few times, and you'll see why it works out this way. It's kind of hard to describe that. But I hope the example here is a little helpful for that. So I'm going to go ahead and turn the screen over here. Maybe I can move it. Oh no, then it takes that away. Everything is connected. That's true. All right, we come over here to the example with the cards. And with our example with the cards, we're just going to work out each of our options. First off, let's do convenience sample. If I live right here, say these are streets on a grid. These are streets, but you can also see your neighbor the other way. There's not really fences. It's just, here's a street. You can see neighbors in all directions. If I was at house number 20, at the 7 of clubs here, house number 20, what would a convenience sample be? I'm at house 20. So this is kind of more, it's more saying, similar to you're sitting at the table. What would be convenient if I was at this location at 20? What, and remember these are just streets and houses. What houses would I go to try to get my sample from? Yeah?
7, 19, 21,
33. I might just go across the street, both directions. I might just go to my side houses here. Convenient sample, is this going to reflect everyone in the neighborhood? Probably not. It might be random who your neighbors are, or you might actually know them. Maybe you knew your neighbor was moving out, so you got your friend in there. You know, there could be things that would give bias. Convenient sample we're never going to use, we're just going to identify. Okay, so the convenient sample, I said, if these were houses, these are houses, I'm in number 20. So our convenient sample would have 7, 19, 21, 33. Because it's convenient, those are all the houses right around me. I have to draw a little darker, maybe use black. So, next. Let's look at doing a systematic sample. So first off, we don't know how many options we're looking for. I'm going to go and put that. We're trying to make a sample of, whoa, that's interesting. Okay, we're going to go ahead with our sample is 13 objects. So first off, how do I know what increment I'm going to go? How do I know which term I'm going to jump at? I'm going to go for the nth term, but I have to figure out which one. How do we find that? How many are in my population? 52. 52. I want 13 objects in my sample, so I'm taking the 52, divided by 13, 4. Now I have to figure, I know I'm going to start somewhere in the first 4 cards. I need to figure out what value I'm going to start at. And I'm just going to do it here because I took away the projector. Apologize. But we're doing, I need one number between 1 and 4. No duplicates. And using the random number generator, we got 3. So I know that I'm starting with 3. I know that my increment, my spaces are going to be skipping 4. So I'm going to go ahead and go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. See, a lot of it is just 1, 2, 3, 4 being organized. 1, 2, 3, 4. 1, 2, 3, 4. You guys get the point? 1, 2, 3. All right, so just do this real quick. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right. So from this, we got our sample. I would go ahead and put in our sample, identifying all those cards with the suit and the value. You see? So with systematic sample, it's probably one of the trickier ones because you got to find the increment and the starting point. Any questions on systematic sample so far? So, you know, if I wanted to put these in my set, I could say here are my spades, and I have a jack, 7, and a 3. For clubs, I have a queen, an 8, a 4. For hearts, I'm going to have a king, a 9, and a 5. And for diamonds, I chose a 10, a 6, and a 2. Okay. So we have the values we need. We needed a sample of 13 objects. So looks like we got to keep going. All right. So then we go 1, 2, 3, 4. We end up with the same one. What did I miss? The ace of hearts. Ace of hearts. Right. So we end up with more hearts than others, but we knew we had to just follow our skip 4 every single time. Okay, great. All right, let's go back to this side. Okay, these two are very similar. The cluster, I want you to think of it as the cluster doesn't care. The cluster doesn't care who is grouped at all. Stratified sample does care who's grouped, and it's really specific. So with the cluster, all you have to do is divide the population into groups or clusters. Then the cluster, into groups or cluster, I'll put this here, number the clusters. I did not add that. We divide the population into groups or clusters, and then we number the clusters from 1 to whatever. Okay. Now, then the cluster is chosen using SRS. So if I needed to find a certain number of objects, I would again look at the total population. I divide it by the objects. That's going to give me my cluster size. So in this case, let's go ahead with looking at this. There's no rhyme or reason to say who is what values are in each cluster, right? It's pretty random here. I just circled. I said I know I need threes. Then I number them 1, 2, 3, 4. I use a random number generator. In this case, say the number was 3. That is the cluster I'm going to look at. Okay. So if I needed my sample to be 10, and there was 100 items, then I would be doing clusters of 10. I would just cluster together 10 objects, 10 objects, 10 objects, 10 objects. And then the cluster I'm going to use is from the random number generator. It's going to tell me that's your cluster you're using. Take your data from there. It does not ask anything of who's in the cluster. It's totally blind to that. But that is different than Stratified. So let's actually do a cluster example over here first. Looking at the cards again, I'll try to use a different color. So let's say we need to have, let's see, 52. Ugh, that's nasty. I'm going to go ahead and take 50 and 52 out of the scenario, so we have 50. Okay. So if we just had 50 cards, these are out of the scenario. Go ahead and cover them. Yeah, perfect. So there's 50, right? I want my sample to be 5. So I would just go in here, and without too much rhyme or reason, I would pick groups of 5. Okay, there's 5, there's 5, there's 5, there's 5. And in this case, these are playing cards. But if this was, if these were students, there wouldn't be any rhyme or reason to it. Okay, that's 5. That's going to be 5. And that's 5. I would go in there and I'd say, here is cluster 1. Here's cluster 2, 3, 4, 5, 6, 7, 8, 9, and 10. That makes sense. There's 5 in each. I know I had 50 to start. I would go to my random number generator. I would click between, I need one number randomly between 1 and 10. If it chose 8, this would be my sample I'm looking at. Okay? Cluster, again, doesn't care that most of them are hearts and diamonds. Cluster does not look at or discriminate at all against what is in the cluster. You can see there's going to be limits to that. If we needed to, for instance, with Stratify, we need to maybe consider the characteristics, and that's the only difference. So let's look at Stratified real quick. Population divided into subsets of people or objects with similar characteristics. If we were doing something that was related to race and ethnicity, we would have to go in and divide the groups into, everyone of one ethnicity or race, and so on, would be split up, and then we would take from each of the samples, or each of the stratified cluster groups. Okay. Here, let's say this is all the students with A's, all the students with B's, all the students with C's, okay, because I want to know a little bit about their experience getting that grade. So I would break them up into similar characteristics, then use the simple random sample, which is just the random number generator, to select the people or objects from each subset. So I would go into each subset. For the kids that got A's, I have between 1 and 3. I have 1, 2, or 3 to pick, 3 kids. So I would do a random generator, number generator. I would get that this is the kid. If I got a 1, that's the student I'm going to take from the first A group. For B's, random number generator got me a 3. That's the kid I'm taking. C's, 1 was picked, random number generator. That's the student I'm taking. So you're taking from each of the groups. And in this case, we already did the cluster. We wanted we wanted 5 objects in sample. So we broke the cluster into just random samples, and we did the random generator to pick who's in the sample. I think we said we had 8. We got 8. So we picked cluster 8 with the random number generator. So that gives me my set of 9 of hearts, 8 of hearts, 7 of hearts, 9 of diamonds, 8 of diamonds. So I didn't write that there, just catching up. Now let's look at the very last bit here. For a stratified sample, how can we stratify these values? What is some way? Talk with your neighbor real quick while I erase some of the parts here. What can I break this into? Do I want to break it into, yeah. How are we going to break up the groups? Really? Continued next period. I can't, or next tomorrow. Sorry. Where did our time go? Yeah. Anything left down here? I'm going to finish the video real quick because I ran out of time. Okay, so I was talking about stratified sample here, and some of the options, ways we can break the groups into. Remember, we want a certain characteristic. So I could say it's all of each suit. That could be the way I break it up. I would then go in and circle, okay, my stratified group is going to be all the spades, all the clubs, all the diamonds, all the hearts. Then I would use a random generator, number generator, to go through and select. You could select 1 at a time from each group to get your sample size, 2 at a time based on how big the sample is. Random number generator would then create my sample group from the stratification, stratified groups of the different suits. So that would allow me selecting 1 from each of my characteristic group would give me my sample down here stratified. Sorry, I missed that. All right, don't forget to subscribe. Jeez.